We now look at projectile motion, and we have already determined that ang projectile motion is essentially two-dimensional motion. And ang two-dimensional motion, therefore, meron kang motion along the x and meron kang motion along the y. So you can see here several examples of projectile motion. Most of the applications ng projectile motion na binibigay natin sa mga estudyante natin actually involves examples that are related to sports, ang karamihan. But of course, there are a lot of other applications for projectiles. So moving now to the meat of our discussion, let's conduct first a short review. Which of these statements are again correct? So again, we will name this one 1, 2, 3, 4, 5, 6, and 7. Okay, so first statement, it is accelerated motion. Is this correct or not? One, yes and no daw. Kinaano na si sir sa aking mga kakulangan. So, number 1 is semi-correct. I think that's the term we are asking for, Sir John Christopher. It's semi-correct kasi kulang siya. Ang correct statement actually natin kasi is that it is actually both dapat constant and accelerated motion. Di po ba? Kasi supposedly nga, it's two-dimensional motion, but the nice thing about it is that it's actually a combination of motion along the x-axis and motion along the y-axis. So it is accelerated motion, but this is only semi-correct because one aspect of its motion is actually constant. Okay? The second is that the third statement, it is two-dimensional motion, is of course also correct because nga meron kang x and y components. Yung number 4, it is a special case of free fall. Is number 4 correct? Okay, so si Ma'am Sherilyn says yes. Actually, yes, it is a special case of free fall. Special case siya kasi it has an x component. So the x component of its motion actually makes it a special case of free fall. So therefore, that leads us to statement number 5, where it is a free fall with a horizontal component. So therefore, we know that this is also correct, pero semi-correct din ulit siya kasi may kulang na condition. And the kulang na condition is actually in statement number 6. It is free fall with a constant horizontal component. Okay? So, because it is a free fall, pero meron siyang horizontal component, ang pagkakaiba ay yung kanyang horizontal component is actually non-accelerated. So, we are going to discuss what is the implication of this one in a little while. So, ito munang number 7. Pasensya na kayo, medyo binibilisan ko tong slide na to. It is parabolic motion. Is it? Yes. Okay. So, it is parabolic motion. Okay. So, essentially, all these statements are accurate except for the fact na some of them have some, may kulang na part yung ating description na binigay. So, the complete descriptions are essentially, therefore, number 2, number 3, number 4, number 6, and number 7. Okay, so yan po yung ating mga appropriate statements regarding projectile motion. Okay, so what is projectile? So the first condition we need to set is ano muna yung forces affecting the motion of a projectile. So here you can see that Paul Hewitt says that ang projectile is any object that moves through air acted only by gravity. So only the force of gravity ang supposedly is acting on the motion. Kaso, minsan, we can also consider air resistance, but for our purposes sa high school and even way back in elementary, hindi natin masyadong kino-consider pa ang air resistance. We only teach that projectile motion is affected only by gravity. So, tinatanggal muna natin ang air resistance by saying that air resistance is negligible. So, there are two components of projectile motion. You have the horizontal component and you have the vertical component. Okay? So, what is happening is that yung horizontal component mo is actually, is just like horizontal motion of a ball rolling freely along a level surface without friction, which essentially says that ang horizontal component natin ay constant velocity. On the other hand, yung vertical component natin is similar to a freely falling object. So that in this case, ano yung constant dito? Kung sa horizontal, ang constant ay velocity, ano ang constant sa vertical kapag projectile na? Okay, thank you, Ma'am Sherilyn. Okay, so it is acceleration. Thank you very much po, Sir Antonio. And opo, thank you po. Medyo na ano lang po, sir. Nablanko lang ng konti kanina. Thank you very much. Okay, so constant velocity and constant acceleration. So it therefore means that if this is the case, then we can say that it's constant velocity. So ang acceleration natin dito ay 0. Pero dito, dahil constant acceleration natin siya, ang ating constant acceleration ay may value na g. And in this case, we say that g is equal to 9.8 meter per second squared. So medyo nakapag-discuss na tayo kanina nito doon sa ating ano. So if you look at the diagram here, at the bottom of this particular page, you should be able to see that there is a small diagram here showing you the two kinds of motion of projectile motion. So you have the horizontal component, which is constant in terms of velocity, and you have the vertical component, which is constant in terms of acceleration. Okay, so therefore, pag sinabi nating projectile motion, what we have is actually ano yan, a combination of constant horizontal motion and accelerated vertical motion. Okay, so now let us see how supposedly ang isang projectile nagiging projectile. So we are going to be using again yung ating simulation, and I'm going to be illustrating it based on the simulation. So here, we will only do the first step. Hanggang dito muna sa kalahati lang ng motion nila. Okay. Okay, so as mentioned a while ago, meron tayong dalawang parts ng motion ng object here, which is the horizontal or along the x, and here, which is along the y. Okay, so mananotice niyo po that if our projectile starts from here, after a specific time interval, ang x component ng motion natin ay nandito na, ang y component ng motion natin ay nandito na, and then what is going to happen is yung combination nitong dalawa, if you combine the two together, you end up with this one. So after another time interval, the x component of the motion is here, the y component of the motion is here. If you combine the two motions together, you actually have this one. And you do the same thing for each of these motions, and then you end up with your projectile actually moving something like this. Okay, so therefore the motion that you see of the object is actually the object combining together yung kanyang horizontal motion together with the vertical motion. And as mentioned a while ago, you can see that supposedly ang ating motion is supposed to be independent of each other in the sense that mapapansin niyo po na yung ating x, equal intervals yan, di ba? Equal intervals yan. Pero mapapansin niyo po yung ating y, you start out with a large y, moving to a smaller y, and to an even smaller y. So ang question is, kung sa x, bakit pantay-pantay ang distance covered? Dito sa y, bakit ang y natin ay paliit ng paliit in terms ng distance covered? Why is it that if you have the, if you look at the x component ng ating projectile, the x component, the distance between the two, the distance between from one interval to the other is equal, pero yung ating y, bakit yung ating interval ng distance ay paliit ng paliit as the object rises to the air? Okay, so sabi ni Ma'am Anife, gravity daw. Sabi ni Sir Jeffrey, it's decreasing velocity. Okay, so if we go back now to our board, and then let's look at our figure. Let's go back here. What we already know supposedly is that in this case, these intervals are equal. Ito yan ay equal, yung intervals natin ng x, because the velocity is constant. So ibig sabihin, if the velocity is constant, then there should be equal distance covered for equal time. Di po ba? On the other hand, dito po sa ating y, what is happening is, first, your object begins with an initial velocity that is large, but because the direction of our acceleration is actually downwards, di ba, pababa yung direction ng ating acceleration, so therefore, what's happening is our acceleration is actually negative. So what we expect is as the ball rises to the maximum height, ang mangyayari sa kanya ay dapat ang velocity niya ay mag-decrease. Okay? The velocity should decrease. So therefore, if we look at this figure, you can see that that is what is happening here along the y-axis. So ngayon, let's answer certain questions that are given in this particular sheet. So the first question is, at what point or points is the velocity along the y-axis 0? Saan po ba daw? Kung alam natin ang ating free fall, the answers should essentially be easy enough to get. Okay, so alam natin that supposedly, ang ating velocity should be 0, v of y will be 0 along the maximum point here. Along the x-axis, meron po bang time na yung ating velocity along the x-axis ay 0? Okay, wala. So, ang v of x natin ay laging not 0. Kasi, supposedly nga, ang v of x natin ay constant. So, kung ano yung initial value niya dito, hanggang sa matapos yan, parehas ang value ng v of x natin. Okay? So, the next one is, at what point or points is the velocity at a maximum along the y-axis? Saan daw ba maximum ang ating velocity sa y-axis? Again, if you recall your free fall, yung ating free fall kung saan meron kang ano yan. Okay, so in short, dito, ang v of y natin is maximum. And dito, ang v of y natin is also maximum. So what you will notice please is that what is happening is dito, you are moving from a v of y na maximum. Diba? Yung velocity mo along the y-axis is from maximum papunta sa 0. Therefore, what we expect is a decreasing velocity. Pero pag papunta na dito sa kabila, what we are seeing is an increasing velocity. Okay? So, ibig sabihin, habang yung object mo is moving upwards like this, the velocity should decrease. But when the object is moving from the high point papunta sa low point, the velocity should increase. So the question is why? Bakit ba na-decreasing ang velocity habang paakyat? Bakit ba increasing ang velocity pag pababa? Nakakatuwa ka, Sir Jeffrey. Alam mo yung mga estudyante ko, yan lagi ang pang-asar nila sa akin. Ang sagot nila, because gravity. Natandaan ko lang. Because gravity, yun ang isa lagi nilang sagot. Okay, so ang dahilan po niyan is let's look at our values now. So when the projectile is going up, habang pataas ang projectile natin, please remember that V of y here is positive, right? You always begin with a positive V of y kasi pataas nga yung V of y mo. However, your acceleration, on the other hand, is negative. So it's moving down. So the direction of V of y and your A are essentially magkaiba. And since magkaiba yan, ang mangyayari niyan is that would cause the V of y to start decreasing because your acceleration and your velocity are moving in the opposite directions. On the other hand, when your object is going down, what is happening is now your V of y is negative kasi pababa na siya, di ba? And at the same time, your acceleration is also negative and is also going down. So in this case, it's going to increase because now your acceleration and your velocity are moving along the same direction. Okay? Kasi remember na doon sa pinakaunang discussion ng sa acceleration, di ba, lagi natin kino-consider na yung acceleration at velocity ba parehas ang direction nila. Kasi kung opposite, that would tend to decrease the velocity. Pag if it's the same, that would tend to increase the velocity. So it's the same thing here. Okay? Going up, opposite directions, therefore velocity will decrease. Going down, the velocity is going to increase because acceleration and velocity are along the same direction. Okay. Okay, so let's move on. Okay, now, this is a very common thing that is discussed in acceleration. And what we have here is actually a ball. We have the red ball is supposed to be dropped to the ground and the yellow ball is supposed to be in projectile motion. So the question we have here is which ball will hit the ground first if they are launched simultaneously? Alin po kaya ang bola na ano? So John Christopher says both balls will reach the ground at the same time. Okay. However, kung both balls will reach the ground at the same time, there are certain conditions that need to be followed, di ba? So, paano po mangyayari yon na yung both balls na yon should reach the ground at the same time? Alin po, sir, ang may velocity initial na 0? Yung red ball or the yellow ball? Okay, so in any case, let us see what is supposed to happen here. And then, bakit ang sagot ni Sir Jeffrey? Okay, so Sir Jeffrey says that they should be launched at the same time. Okay, so we therefore already have fixed the first condition na dapat launch siya at the same time. So they are launched simultaneously. So at what condition should exist for both balls to reach the ground at the same time? So kung babalikan po natin yung ating figure kanina, you will notice please that that particular figure will essentially show you that ito yung dropping down like this, and at the same time, we have the yellow ball. So yung yellow ball, ang pagkakaiba ng yellow ball ay meron siyang horizontal component. So we know that the yellow ball is a projectile, so what we expect is that it will actually have a constant horizontal motion in this manner. So therefore, when the red ball is here, the yellow ball actually will be somewhere here, right? And when the red ball is here, the yellow ball will actually be here, and so on. So that if we fix a certain condition, then that means that as the red ball drops downward, habang yung red ball natin nagda-drop downward siya ng paganito, yung ating yellow ball din should be dropping to the ground in this direction. Okay, following this one. Sorry, hindi ko na sinundan yung line. Following this one. So that we know that what is happening here is that these two objects should essentially fall to the ground at the same time. Pero ano yung condition? Ang condition ay dapat yung red ball natin, ang velocity initial niya dapat 0. Ibig sabihin, dapat yung red ball natin drop. Now, si yellow ball, hindi pwede na si yellow ball, ang initial velocity niya ay 0, di ba? Kasi si yellow ball has to move forward as well as down. So in order for yellow ball to do the same motion as the red ball, what we need to do is we need to actually give the yellow ball a velocity initial. However, ang velocity initial ni yellow ball is actually dependent, is actually also governed by yung kanyang tawag nito, ay governed ng kanyang horizontal component at ng kanyang vertical component. So para si yellow ball at si red ball ay parehas ng i-drop na distance, kailangan si yellow ball, ang velocity initial niya along the y should also be equal to 0. Okay? So, in that case, ang natitira na lang dapat ay ang velocity initial ni yellow ball along the x should not be equal to 0. So in short, in the case of the question as to what is the condition for these two to fall together, dapat si yellow ball at si red ball, parehas dapat sila ng y. It should be both equal to 0. At the same time, si yellow ball should have a non-zero na horizontal velocity. Now, why do we know that they reach the ground at the same time? Kasi they fall the same vertical distance, di ba? The same vertical distance to eh. So, ang nagmamatter naman sa falling to the ground is actually yung vertical distance. And because it is the vertical distance that actually matters, so what happens is they should drop to the ground at the same time because their vertical components are essentially the same. Ang pagkakaiba lang ay si yellow ball, meron pa siyang horizontal component. Okay? That is the difference between the two balls. Okay. Sige. So, medyo sobra na ako sa overtime, ano? So, I already essentially, okay, so let's discuss this one. Okay, so this one essentially shows you the equations that are needed for you to be able to look at how objects that are in projectile motion are launched. Nasa mathematical part na po tayo and some of you are already very comfortable with this. So as you can see here, naalala nyo, diniscuss na natin that b of y is equal to b sine theta and b of x is equal to b cosine theta. So in this case, instead na theta, ang ginagamit natin ay angle na theta sub O, alpha sub O. So here you can see that the initial velocity of a ball that is asked to go through a projectile motion has an initial velocity that is the initial times the sine of the angle, and the velocity initial along the x uses the expression cosine. So ito po yung angle of launch. Ang tawag po natin sa kanya ay angle of launch. Okay? So the rest of the description for what happens to a projectile can actually be essentially just look at it from the point of view ng free fall. Okay, so here is an example where you actually have the combination already of two motions, yung horizontal and vertical. So kanina diniscuss natin yung yellow ball and in this case, most of the time ang ginagawa ko nito is this is actually a problem in Catnell. This is a sample problem. But I don't give this to my students na nakabigay na yung problem. So what I usually do is I usually ask them to solve this one on their own by creating their own problem out of it. Okay. So as an example, so nakikita na ninyo dito na at the beginning, here, you can already see na nakalagay lang dyan ay b of x is equal to 115 meters per second. So we already know that in this case, velocity initial y is actually equal to 0, okay, from here. And then, ang nangyayari nito ay minsan, binibigay ko ito sa mga estudyante and then kayo nang bahala mag-determine ano ba ang hahanapin nyo. Okay, so sometimes, some students will just simply solve for v of y, yung v final y daw, yung velocity final y dito. Sometimes, the students will start solving for t. Ano daw yung t? And then sometimes, the students will start solving for x. Okay, so what is important here actually in this kind of problems is that by solving each one of these, makikita mo kung ano yung level ng estudyante in terms ng kanilang alam sa alam tungkol sa projectile. So as an example, you can start by solving the fact that mag-solve tayo ng konti, no? LJ, sobra na ba akong overtime, no?
It's okay, Ma'am Jo. Okay lang po.
Hayaan mo, madali na ako matapos.
Yes, po. No problem.
Okay, so let's try by solving for x. Okay, so let's try to solve for x. So we already know that supposedly, ang v of x natin is constant. Okay, so constant to. So v of x in this case is actually equal to x over t. So if we want to solve for x, we actually want to solve for x is equal to vx of t times t, di ba? Ito dapat yung ating working equation. Kaya lang mapapansin nyo na ang given lang naman natin ay v of x. Kung titingnan nyo yung buong figure, wala kayong makikita dyan na t. So in short, yung t hindi natin masosolve using x. So what is supposed to happen is now you need to look at the y. So you need to look at the y-axis. And by looking at the y-axis, you should be able to come up with a solution. So from the problem itself, nakikita naman dyan na ang velocity initial y natin is supposed to be equal to 0. Kasi di ba, ang ating object ay horizontally launched. And also, from the same one, we know that we are given that y is equal to negative 1,050 meters. Nandito po yan. Okay? Aside from that, wala nang ibang given. So ngayon, papasok ngayon yung ating alam tungkol sa projectile, in which projectiles are supposed to be free fall. So therefore, we know that acceleration in this case should be equal to 9.8 meter per second squared. So ito lang yung given. E paano yan magko-connect dito sa t? Sa x, how do we connect these two? What we know is that actually, the time needed for the object to move forward, which is the t of x, should be the same time needed by the object to drop to the ground, which is t of y. So if we can solve for t of y, kung masolve natin si t of y, masasolve natin si t of x. And therefore, we can solve for x. So with just this given, paano ba tayo magsasolve? We already know that we have certain equations that we use for this kind of problems. We call them uniformly accelerated motion equations. So we start with v final is equal to velocity initial plus at. And you have, x ba yun? Sorry, y pa lang ginagamit natin. Sorry. Y is equal to velocity initial plus velocity final over 2 times t. And then you have y is equal to velocity initial times t plus 1/2 at squared. And you also have 2ay is equal to velocity final squared minus velocity initial squared. Okay, so hindi na natin to siya dinerive kanina kasi ang assumption natin ay you have already used that when you discuss about free fall. So therefore, if we try to look at this one and see, makikita natin na ang pinaka-fit sa ating given, if you look at our given, you have velocity initial, you have y, you have a, and you have t. The best fit is actually yung ating equation number 3. Okay. So of course, you ask your students to do this so that you get y is equal to velocity initial t plus 1/2 at squared. So of course, what happens is you have the given here, pero para madali ang solution, normally tinatanggal na natin itong 0 kasi ang velocity initial ay 0. So we are left with y is equal to 1/2 at squared. So from here, we solve for t by first cross multiplying 2y is equal to at squared. and then we divide both sides by a. So that we get 2y over a is equal to t squared. And then we can extract the square root both sides and change so that we have t is equal to 2y over a. So we can now substitute our given. We have 2 times negative 1,050 meters all over negative 9.8 meter per second squared. So therefore, we get t is equal to 14.6 seconds. And there, we can therefore already solve for x. So that x is now equal to v sub x times t. So that will be 115 meters per second multiplied to t, which is in this case 14.6. So you get an x that is approximately about 1,683 meters. Okay. So this kind of solutions, sanay tayo na binibigay sa estudyante, pero ang important, I think, is for them to realize that you can actually solve the equations separately, yung x tsaka yung y. Okay? It's possible to solve the equation separately between x and y. Okay, so that is one way by which we can do that. And this one is actually something that I give to my slightly advanced students in case na kailangan problem. And usually, ang binibigay kong challenge problem sa kanila ay ito. Does the angle of release of a projectile remain constant throughout the motion? Okay? So, does the angle of release remain constant? Yun po yung question na ating inaano dyan. So, you can give this to them, you can give them this figure, and then you can ask them to analyze. So, there will be a lot of different ways of answering this one. Pero yung siguro pinaka-genius na paraan ng pagsagot nito ay yung sagot ng isa kong estudyante na, ma'am, obvious naman, di ba, dito sa taas, na yung angle natin dito ay reduced to 0 degrees. Di ba? Ang angle dito ay 0 degrees na. Kasi, ang natitira na lang dito is yung vertical. Kasi, yung velocity initial y mo ay equal to 0. Yung v of x mo na lang ang nandito na not equal to 0. And the angle here is supposed to be equal to 0 degrees na. But, you can ask them na, can you give me better proof by solving for this part or maybe solving for this part. So, I will leave that to you to give us an exercise if you want to give it to your more advanced students yung ganitong klaseng problem. Okay. So finally, let's go over this one. This is projectile motion, and in the case of projectile motion, we have already mentioned, and you can actually do this summary table after a lecture and ask your students to do the same. Kung ano yung pagkakaiba ng x component ng projectile and yung y component ng projectile. So, yung type of motion ng projectile, it's supposed to be constant velocity along the x and free fall along the y. And then you can ask them to describe what happens to the velocity. Okay, so constant ang magnitude and direction ng x component and increases or decreases in magnitude along the y. Okay, so this one is because of the acceleration na na-mention na natin before kanina. So going up, decrease. Going down, increase because of the direction of the acceleration. And then we have the acceleration is 0 and gravitational. And ang common characteristic nila is the time needed for both horizontal and vertical motion are equal. So you can again ask your students to try to prove this one if it is indeed equal. And then yung parabolic characteristics niya, of course, the range of that one will depend on the v of x, yung ating initial launch velocity. Samantalang sa case ng y component, yung ano niyan is yung symmetry ng going up and going down. So that if we look at this figure again, and if your object essentially starts from this point and ends along the same displacement point here. So parehas na level yan dapat. So what we expect is dapat yung velocity niya dito, the velocity at the initial should be equal to the velocity of the final. So ang question is, can this be proven? Okay? Okay, so from there, I have here extra slides for you to look at in terms ng kung ano, paano ba ang projectile na consider na parabola. There is a certain discussion here. Same thing kung bakit yung angle na 30 degrees is considered to be the, ano yan? So just very quickly kung bakit 30 degrees. Without doing the computation anymore, we know that R, or the derivation anymore, is actually equal to V squared sine 2 theta over G. So ang alam natin is that ang maximum range is supposed to occur at 45 degrees. Okay, so bakit 45 degrees of all the angles? You will notice that that is sine 2 theta. So that if theta is equal to 45, then you will have sine times 2 times 45 degrees is actually equal to sine 90 degrees. And sine 90 degrees is actually equal to 1. Okay? So this is the reason why the maximum range for each one is actually 45 degrees na angle. Finally, last slide. Nakakapagod, no? Okay, so let us do the concept check. Let's start with the first figure. Sa tingin po ba natin, dapat yung archer should aim higher, lower, if he or she wants to hit the target? Okay, so sabi ni Sir John, higher. Okay, so higher siya kasi what we expect is that supposedly, yes, without the effect of gravity, the expectation is the arrowhead is going to hit here. But however, because of the effects of gravity, there will be some bending that will occur. So the actual path of the arrow is actually something like this. So therefore, they should aim higher. Yung other picture, this one, where you have a zookeeper and a monkey, kung saan yung monkey po is on a tree, pero once the zookeeper throws the banana to the monkey drops to the ground. So should the zookeeper be aiming higher, lower, or on the monkey itself? Ito kasi the target is not moving. So it's okay to aim higher, but in this case, the monkey is going to drop from the tree. So should the person throw the banana directly at the monkey, or should he or should she throw the banana higher than the monkey or lower than the monkey? Okay, sabi ni Sir Jeffrey at monkey. Opo, kasi ang mangyayari po is, again, what's going to happen is our banana is going to be describing this motion. So ibig sabihin, ang mangyayari is as the banana moves this way, the monkey is also moving down this way. Okay? So therefore, what's going to happen is that the monkey and the banana will actually collide at a certain point, even if the zookeeper aims at the monkey. So in this case, aim directly. Okay? So that's the difference po between the situation given by for the zookeeper and the situation given for the archer. Okay, so I apologize for the very long lecture. I did not anticipate it will take me so long to discuss the first part, but I hope that something has been transferred from me to you at this point. If there are anything else that you would like to clarify, you can, of course, just simply also message me pa kung sakali. Pero I think I'm done at this point. LJ?
Ayan, no problem po, Ma'am Jo, and maraming salamat po as always. And I am fairly confident naman po that the discussion was really help our participants grow their knowledge. And with that, the session's goals have been met. Really. Ayan, so nag-note lang po ako ng konti dito, and our participants, I'm confident, gained a deeper understanding of the concept that they would have otherwise, going beyond the usual equations. That's 101%, of course. And kakaiba po ang problems na pinakita po, di ba? Some of the problems were that of really situational, real life, and the way that were presented were aesthetically pleasing. And overall, the discussion is very informational, very insightful, and very engaging since, ayan, magkakaroon po tayo ng interaction during the discussion with our participants. So I hope you were made realize and appreciate how beautifully math and physics function by Ma'am Jo's presentations.